The last video to do with rates of reactions and collision theory is on catalysts. Now, what is a catalyst? What does it do? A diagram here is an energy profile diagram, and we're going to use that to explain the role of a catalyst in a reaction. So a catalyst is something that increases the rate of reaction by decreasing the activation energy. Here I've got an energy profile diagram which shows the energy held by the reactants and the energy held by the products. You can see there's a large lump of energy that needs to be overcome. This is our activation energy. Our blue line here shows the activation energy when we don't have a catalyst present, and you can see it's much larger than the red line, which shows our activation energy when we have a catalyst present. The catalyst doesn't change the amount of energy stored in the reactants or the products, so therefore the energy released from the reaction, which is our delta H, remains the same. All a catalyst does is decrease the activation energy, and in doing this, it actually increases the rate of reaction. To explain how it increases the rate of reaction, we need a Maxwell-Boltzmann distribution, like this one here. So a Maxwell-Boltzmann distribution really goes the extra mile in terms of explaining why the rate of reaction increases based around collision theory. Again, by definition, collision theory states that for a reaction to occur, particles must collide with sufficient energy. And therefore, if you provide more particles with the right amount of energy, you'll have more frequent successful collisions. So here I can see that energy is on our x-axis and number of particles is on my y, so the area underneath my graph refers to how many particles have a certain amount of energy. In an uncatalyzed reaction, you have a higher activation energy, and that's shown by this red shaded area here. Our catalyzed activation energy is lower, so therefore my blue and my red all have the activation energy required to react if we have a catalyzed reaction. What this does is it shows the fact that we have an increased proportion of particles that have the energy that can react. Thus, we have an increase in the frequency of successful collisions because we have a greater proportion of particles with the activation energy. Key words here when describing how catalysts affect our rate of reaction is using that term proportion, because we haven't increased the number of collisions, because we haven't changed the amount of energy. What we've done is we've just increased the proportion of those collisions which are successful. So by increasing the proportion of successful collisions, we've increased the frequency of these successful collisions. And thus, my rate of reaction has increased.